This is a profoundly challenging topic, situated at the intersection of astrophysics, neuroscience, and cognitive philosophy, where the rigid boundaries of the material universe collide with the boundless flexibility of the human mind. To address what appears to be a straightforward yet deeply profound question piercing to the core of reality itself, whether consciousness or the speed of light prevails in swiftness, we cannot merely pit two measurements against a stopwatch. Instead, we embark on a meticulous dissection of reality's essence, from the journey of a minuscule light particle, a photon, traversing the frigid vacuum of space, to the leap of a tiny sodium ion across a delicate neuronal membrane, sparking a fleeting thought within our skull. Imagine us poised at a crossroads of knowledge, one path lined with the unyielding precision of physical laws, the other shrouded in the enigma and fluidity of the mind. Let us commence by establishing the first contender in this imagined race, light itself. Within the framework of modern physics, a cornerstone forged by Albert Einstein's monumental special theory of relativity, the speed of light in a vacuum, denoted as the letter c, stands as a fundamental universal constant, an immutable figure clocking in at approximately 299,792,458 meters per second. Pause for a moment to absorb this magnitude. It is nearly 300 million meters every single second. For perspective, if one could travel at this velocity, encircling our Earth, with its equatorial circumference spanning roughly 40,000 kilometers, would occur 7.5 times over in the blink of an eye, that mere sliver of a second. This velocity governs not only the propulsion of photons, those pure packets of energy devoid of rest mass, but more crucially, it enforces the universe's supreme limit on causality. No matter or information can breach this threshold. Light dictates the pinnacle pace for all interactions, every propagation of influence. It forms an impenetrable physical barrier, serving as the benchmark for all motion across space and time. Gazing at the night sky, the light from distant stars arrives as historical snapshots, messages that have journeyed millions, even billions, of years to reach our eyes. Yet, as we pivot our lens inward, contracting our gaze from the vast cosmos into the confines of the human cranium to scrutinize the second contender, consciousness, the tableau grows far more intricate and, in purely physical terms, astonishingly sluggish. Consciousness, as comprehended by contemporary neuroscience, emerges not as a solitary entity but as an emergent masterpiece, a symphony orchestrated from the electrochemical symphony among billions of neurons, those intricate cells forming the brain's architecture. Recent advancements in brain mapping, such as the Allen Institute supercomputer simulation of an entire mouse cortex released just days ago in November 2025, have illuminated how these networks process information at scales previously unimaginable, enabling virtual experiments that mimic diseases like Alzheimer's or epilepsy with quadrillions of calculations per second. This underscores the brain's computational density, yet even these models reaffirm the inherent delays in biological signaling. Envision the human brain as an immense biological computational grid. Neural signals, the very threads weaving our thoughts, emotions, and perceptions, do not surge like electricity through copper wires at velocities approaching light speed. Rather, they manifest as action potentials, electrical impulses born from the exquisitely orchestrated migration of charged ions, such as sodium, potassium, and calcium, across fragile cellular membranes. This ion flux, akin to electronic gates flicking open and shut, generates a propagating wave along the axon, the neuron's elongated fiber. The propagation velocity of these signals hinges profoundly on the axon's physical makeup. Notably, the presence of myelin sheathing plays a pivotal role. Composed chiefly of lipids and proteins, this myelin acts as a rubbery insulator encasing the axon. It facilitates signal leaping from one gap to the next, termed nodes of Ranvier, via saltatory conduction, dramatically accelerating transmission. Neurophysiological studies have established that the swiftest neural impulse conduction in the human body, typically urgent signals like proprioceptive cues for body position or rapid motor commands to muscles demanding instantaneous response, peaks at about 120 meters per second, equivalent to 432 kilometers per hour. This represents biology's zenith. Consider, however, unmyelinated fibers, where speeds plummet to a mere 0.5 to 2 meters per second. Such paces lag behind the average brisk walk of a healthy individual. Picture an anxiety signal traversing from toe to brain. It demands considerable time compared to a light beam slicing through air. In a direct physical showdown, light outpaces the neural signals underpinning consciousness by roughly 2,500,000-fold. An colossal velocity chasm, virtually unbridgeable in the material realm. Emerging research from the University of Southern California in October 2025 on artificial neurons using ion-based diffusive memristors further highlights this disparity, as these synthetic mimics replicate biological processes but hint at future hybrids that could bridge the gap, though human biology remains tethered to these limits. The lag in consciousness sharpens into stark relief, and induces awe when we probe information processing timelines. Consciousness, as we encounter it, shuns immediacy, it mandates inherent delays. Consider a lightning flash illuminating the sky. Photons bearing luminous energy strike your retina almost instantaneously, courtesy of light's prodigious pace. Yet your brain does not register it forthwith. Time elapses for transducing photonic energy into electrochemical signals, relaying through the intricate optic nerve, navigating relay stations like the thalamus, and culminating in specialized visual cortex regions to interpret the spectacle. Iconic experiments on reaction times and awareness, spearheaded by Benjamin Libet in the 1980s, posited a startling revelation: a preconscious delay spanning 300 to 500 milliseconds precedes our actual awareness of a decision rendered or sensation arisen. This half-second interlude, trivial in daily rhythm, carves a vast perceptual void. It yields a philosophical, even unnerving, inference: we never inhabit the flawless present tense. The now you sense, the sounds you hear, images you behold, constitutes a dispatch delayed by about half a second from the unfolding physical actuality. We dwell eternally in a sluggishly refreshed rendition of the past. A pivotal query thus arises: why do our thoughts seem swifter than light? How can we contemplate Sirius, the star 8.6 light-years distant, instantaneously, while its photons require nearly 9 years to traverse to our gaze? Herein lies the crux, where comparison shifts from raw physics to metaphysics and the brain's extraordinary simulation apparatus. A landmark experiment from the Allen Institute, detailed in late 2025, has newly illuminated consciousness origins, challenging rival theories by tracing neural correlates with unprecedented precision, suggesting predictive mechanisms that anticipate events mere milliseconds ahead, blurring the line between delay and foresight. Consciousness's apparent swiftness resides not in the corporeal velocity of electrochemical pulses but in nonlinear retrieval and simulation prowess. Contemplating the remote Andromeda galaxy, your mind dispatches no tangible signal, no particle stream or energy wave, vaulting cosmic voids for a reply. Such a notion defies physical feasibility. Instead, your brain executes localized data recall, igniting a pre-wired neural lattice encoding Andromeda's essence on-site, within your cranium's three-dimensional confines. This unfolds as accessing pre-existent information. Thus, thought speed here equates to neural systems' memory access rapidity, not spatial traversal velocity. Given the brain's minuscule internal distances, mere centimeters between regions, interlinking concepts and intricate ideas feel subjectively instantaneous. Moreover, consciousness wields a marvel-like cannot, leaping across space and time within its intrinsic models. Light remains shackled to causality and space-time continuity. It traverses every continuum point from origin to terminus, A to Z, omitting none. Consciousness, conversely, thrives on brain-constructed internal simulacra. Seated tranquilly in a Hanoi office, your mind in a flash alights on Mars's surface, sensing crimson dust and surveying a teal-grey sky. No need to ford the 225 million kilometer void. In the inner realm, physical distance collapses utterly. With zero spatial separation, classical velocity dissolves into irrelevance or infinity. This epitomizes imagination and cognition's potency, emancipation from corporeal spatial fetters. Recent quantum cognition models, explored in a 2025 Frontiers in Human Neuroscience paper, extend this by positing quantum principles in decision-making, where superposition enables parallel processing that mimics such leaps at subneuronal scales. To enrich this discourse, we must invoke a captivating, contentious facet riveting scientific circles, the quantum consciousness hypothesis. Exemplified by Sir Roger Penrose, the eminent mathematician and theoretical physicist, alongside Stuart Hameroff, the anesthesiologist and consciousness investigator. Their orchestrated objective reduction theory, OR, posits consciousness transcends classical electrochemistry, originating in quantum computations within neuronal microtubules, those nanoscale scaffolds. A groundbreaking April 2025 experiment on a superconducting quantum computer furnished proof of wave function collapse, bolstering Penrose-Hameroff tenets by demonstrating testable quantum effects in macroscopic systems, as reported in quantum computing journals. This aligns with microtubule research linking anesthetics to intraneuronal quantum disruption, per a July 2025 Oxford academic study, suggesting these structures as anesthesia's precise targets and consciousness's quantum bedrock. Should consciousness harbor such quantum roots, quantum entanglement may factor in. Quantum mechanics depicts particles mysteriously linked, wherein one particle's state instantaneously sways another's, irrespective of separation. Einstein derided this as spooky action at a distance, seemingly flouting light-speed bounds. Though entanglement precludes superluminal information transfer, measurement collapses the state, necessitating classical channels for comparison. If our biological brains harness this at foundational strata, consciousness's physics might operate non-locally, atemporally. Yet, this remains a nascent hypothesis, courting substantial skepticism from mainstream science, which contends the brain's warm, wet, chemically turbulent milieu cannot sustain fragile quantum states long enough for quotidian cognition. The 2025 Science of Consciousness Conference in Barcelona amplified these debates, with plenaries on quantum fields and consciousness, including Donald Hoffman's traces of awareness shaping spacetime physics, underscoring the theory's evolving traction amid empirical scrutiny. Gazing ahead, the consciousness light velocity contest may dramatically evolve amid artificial intelligence's ascent and humanity's pursuit of high-tech frontiers like mind uploading. Human biological consciousness, constrained by ion conduction's lethargy, capping at 120 meters per second via biochemical dictates, may soon yield to silicon or photonic substrates. Photonic computing, leveraging photons for data handling, propels signals near light speed. In such paradigms, thought velocity and light converge, potentially inverting precedents. A digitized intellect could cogitate millions-fold swifter than biological kin. Our subjective year might equate to mere computational seconds for the digital entity. Thus, consciousness transcends imaginative light-speed mimicry, embodying it operationally. Georgia Tech's June 2025 TopoNet's algorithm, a brain-inspired AI breakthrough, exemplifies this, slashing energy demands while accelerating simulations, paving neural emulation paths. Yet, skeptics like neuroscientist Christoph Koch in September 2025 essays caution that true consciousness eludes upload, as qualia, the raw feel of experience, defies mere pattern replication, per essentia foundation reflections on cloud immortalities and fell to lure. Ultimately, to furnish a substantive riposte to this perennial inquiry, which prevails in speed, we must embrace a dualistic verity, contingent on our vantage. In the material cosmos, mitted in meters and seconds, where interactions bow to the ultimate velocity cap, light reigns supreme, dwarfing the plodding electrochemical creeps threading our neural bundles. As biological beings, we lumber astonishingly in cosmic context, ensnared in past's lag, straining to overtake fleeing physical now. Light's pace endures immutable. But in semantics cosmos, informations weave, conceptual linkages, and non-linear simulacra, consciousness commands unbound. Light requires 100,000 years to span our Milky Way, an inconceivable expanse. Human consciousness, via a crude law, erudition, and preeminently imagination, engulfs the galaxy, transcends observable universe frontiers, even conjectures pre-Big Bang epochs, all in a neural spark's evanescent blaze. Light, steadfast and absolute, illuminates, unveils, furnishes raw cosmic data. Consciousness seizes, deciphers, imbues meaning, delineates that cosmos. Thus, perhaps reality's paramount velocity concerns not physics, but comprehension celerity, awareness's acuity, mind simulacrum might. In this contest, light serves as conveyance, consciousness, the sovereign navigator.